Hi, my name is Ron Furstenau, and I'd like to welcome you to First Lutheran Church's three-lesson seminar on science and religion. This is the second lesson, and on this second lesson, we're going to focus on what I like to refer to as the big things, and that will become more apparent as we go along here. We're going to be talking about cosmology, the significance of mathematics, evolution and creation, and something called intelligent design. On our first lesson, we really looked at introductory things like terms that people use in discussing science and religion. We saw that although there are conflicting views, some conflicting views on science and religion, I believe that they are complementary paths to the better understanding of God. It's always important to remember that science and religion answer different questions and ask different questions. Science wants to know how and why, whereas religion tries to answer what it actually means. Over the centuries, many scientists of faith have regarded the wonders of the universe as another Bible and something to be understood through science as a way to more fully understand God. And that's what we're going to emphasize on these next two lessons. I'd like to start out with a discussion about cosmology, that is, an account of the creation of the universe. I think my first awareness of the greatness and beauty of God's creation occurred when I was 16 years old and we had a nighttime physics class in high school. And it was the first chance I ever had to look through a telescope. And I remember seeing the planet Saturn. Through this telescope, it was just a white dot, but you could clearly see the rings. And I'd read so much about it in high school, but now I actually got to see it, and it stuck with me all my life. But a similar thing happened to me when I was 23 or 24 years old. I was working with a rocket engineer at the Jet Propulsion Laboratory in Pasadena, California, which was the headquarters for most of NASA's unmanned programs. It was during the era of Voyager 1 and 2, which were spacecrafts that went beyond Mars to Saturn, Jupiter, Neptune, and Uranus eventually. We were having lunch in the cafeteria together, and they had big TV sets mounted all over the cafeteria. And what you would observe on those TV sets was pixel by pixel, line by line. It was showing the picture, what the cameras were picking up from the Voyager spacecraft. And eventually what you saw was the development of a picture of Saturn and as it was getting by a close by approach. I remember just staring at it for a couple of minutes because I simply could not believe that that's what I was actually seeing and all of the technology and people that went into developing that whole program. And it kind of made me think about the fact that, gee, God gets to observe this every single day. And observing both when I was in high school and at the Jet Propulsion Lab really made me aware of the awesomeness of God's universe. As I mentioned in the first lesson, the Bible is not a science book. As Tom Rudilius, who is a theoretical physicist and a Christian, states, and I quote, "I've come to understand that the Bible is not primarily a science textbook or a list of rules or a collection of newspaper articles. It's primarily a story of a lost, wayward, rebellious people and a God who through Jesus would stop at nothing to bring them home. This is the overarching story of the Bible. Christianity's bold claim is that this is also the true story of the world." Rudilius's point is a good thing to remember as we relate what science says about the origin of the universe versus the Bible. Well, what does science say about the origin of the universe? Most of you are familiar with the concept of the Big Bang. And this is, in my view, one of the key agreements between the Bible and science is that the universe had a beginning. The Big Bang says the universe occurred from a single location with all of the matter emanating from a small, incredibly small point. What is not known from a scientific standpoint, however, is what the origin is of that point. Science says that the universe is about 13.8 billion years old, with the clock starting at the Big Bang. And to most people, myself included, this is an unimaginably long amount of time. But it's determined by analyzing the light from deep space, how long it takes the light to reach the Earth. In addition, we look at the redshift, the Doppler shift, and that's been known since the late 1920s. When we observe this shift, we can tell that the universe is receding. It's expanding. We also look at the cosmic microwave radiation background, also helps us to determine the age of the universe. What we also have to remember, and we'll talk about this in a couple of minutes, is that all of this determination of the age of the universe, we use this experimental data in conjunction with mathematical models. Science also says that the Earth is about 4.5 billion years old. This too is just an unimaginable amount of time. How is this determined? There's a technique called thermal ionization mass spectrometry, which looks at different ratios of what we call isotopes, which are simply elements with different numbers of neutrons but the same number of protons. These isotopes, we can measure the ratios based on some of them being radioactive, some of them not being radioactive, and based on the half-lives determine the age of these rocks, whether they're Earth rocks, extraterrestrial rocks from meteorites, or moon rocks. Science also says that there are between 10 to the 22nd and 10 to the 24th, which is a septillion, stars in the universe, which is also an unimaginably large number. As large as it is, you might remember when I inflated the balloon last time, it turns out that that number of molecules of air inside the balloon is roughly the same as the number of stars in the universe, right? So that kind of gives you a perspective on the size of atoms and molecules. It's also estimated that there are about 10 to the 85th total atoms in the universe. Almost all of those atoms in the universe are hydrogen and helium, which are the simplest elements on the periodic table of the elements. If our scientific knowledge and understanding is right, the larger elements got formed by the birth and eventually the death of stars, with that material agglomerating into planets eventually. Now, what does the Bible say about cosmology? Well, it's important that you read Genesis 1 and 2. If you work back from the genealogies in Genesis, the biblical date of creation is between 5,500 and 4,000 BC, about 6,000 years ago. That method of dating the Earth, that's often called the young Earth theory. But then that brings up, well, what about the fossil record? And what about scientific dating techniques? Acceptors of the young Earth theory say that if God created everything, he could certainly have created the fossil record and the isotope ratios that we currently see. Although it's hard to argue that he certainly could have done that, I don't believe that he did. And I don't believe that it conflicts with my Christian beliefs either. I do want to quote from the Lutheran Study Bible. It says, worldwide, there is a diversity among Lutherans regarding the interpretation of the days of creation in Genesis 1. The Lutheran confessions do not mandate the belief that God created the world in 6 24-hour days. Many Lutherans understand that science helps us to understand how God created the heavens and earth. Whatever the case is, all Lutherans are united on the confession that God created it all. And again, I believe that nature and creation are yet another Bible that God has given us to understand, and that science helps us to understand this other Bible. The Bible lets us know that God created the universe. It's not a science book, but Genesis essentially says that God was ultimately responsible for the existence of everything. Simply doesn't tell us how he did it. Right? Some people feel that the Bible, being the Word of God, cannot contain any errors. So they feel that calling into question any of the account of Genesis, of creation in Genesis, leads us down a slippery slope of calling into question the Word of God. I really have a different opinion on that. I believe that God wanted us to understand as much as we could about how he created the universe. He created us in his image. God created all things, and he wants us to know through science what he actually made. Right? Also, according to the Lutheran Study Bible, because the stories of Genesis came from so long ago, compiled over 5 centuries, and were passed down verbally before ever being written down, it's difficult to verify the extent to which the stories of the men and women of Genesis reflect actual historical figures, and particularly this is Genesis 1 through 11. To me, the different accounts of creation in Genesis 1 and 2 really doesn't matter. To me, and this is where science agrees with the Bible, the most important line in the creation story matches exactly what science says. There was a beginning. Genesis 1:1 says, in the beginning, when God created the heavens and earth. And perhaps John 1 says it better. In the beginning was the Word, and the Word was with God, and the Word was God. He was in the beginning with God. All things came into being through him, and without him, not one thing came into being. Right? The ordering plan to me of the universe and the identity of the planner is clear. It was God. Right? It doesn't make sense to me that at the time that Genesis came about was orally handed down and written. It doesn't make sense to me that God would have thought that it was important to tell people at the time exactly how creation was done. They probably wouldn't have understood it anyway, and probably wouldn't even understand it now. But I see no incongruency with scientific beliefs and the fact that the Bible says that in the beginning God created the heavens and the earth. I think something with respect to cosmology is important to point out with respect to the earth. It's certainly an important thing to all of us that there's something about the perfectness of our planet Earth for life. The atmosphere is the perfect composition to filter out harmful radiation or light from the sun that would be harmful to life, yet it lets precisely the right wavelengths of light in for photosynthesis, right? Oxygen atoms on Earth, they're 10,000 times more plentiful on Earth than the main constituent, nitrogen, in the atmosphere, but most of it's in rocks. But there is 21% of the atmosphere is oxygen, and that's essential to higher life forms. And all of that is due in the atmosphere due to photosynthesis. And I think perhaps the most important thing about what we have on Earth is there's plentiful amounts of liquefied water. Liquid water is really the key chemical compound to Earth and the formation of all and the existence of all living things. You have to ask yourself, are all of these things by chance? And doesn't the perfectness of Earth for life point to God's hand? And I think that it does. Now, I think another part of science that's really important to understanding the miracles that we see of God's creation is mathematics. Herman Wauch is a famous author who wrote, among other things, The Caine Mutiny. He did an interview with Richard Feynman, a Nobel Prize-winning physicist, and he had this exchange. Feynman says, "Do you know calculus?" And Herman Wauch admitted that he didn't. And Feynman says, "You'd better learn it. It's the language God talks." Feynman's point was this: if you want to know how things work in the world, you need to understand mathematics. It's the common language of science, and I couldn't agree more. Now let's talk about some terms that are often associated with mathematics and mathematical models. In science, laws describe what we see, but it really doesn't describe why we see it. For example, Newton's laws of motion, Newton's laws of gravitation. He proposed these laws based on experimentation and observations, but really didn't know why they should be true. Whereas a valid scientific model allows us to suggest observations or predicts outcomes that have yet to be observed. In other words, models help us to predict the future. When a model expands and it explains more things that match experimental data, it allows us to abandon other models, and that model then becomes a theory. A theory hopefully will provide an explanation for why laws exist. Newton's laws of motion and laws of gravitation, they've existed since the beginning of time. Newton didn't invent these laws, he discovered them. But again, these laws describe much of what we see in the universe, but not why. And it turns out Einstein's theory of relativity, however, does address the whys of, for example, the law of gravitation. And the models and theories that scientists use to describe our universe, they're mostly mathematical ones, and they're almost always calculus-based. It's often said that Isaac Newton invented calculus, but I think calculus has always been there. Newton just simply discovered it there. And there are lots of simple models and theories in science, and many of the simple mathematical ones are often not correct, but are accurate enough to predict things. And the behavior of gases is one of these. And let me describe what we mean by a law for gases here. We have the balloon demo from last time. I'm going to inflate the balloon. This time I'm going to tie off the balloon. Now, we've probably all done this before. If we have the balloon, there's a set number of molecules in this balloon since I tied the balloon off. If I press down on the balloon, you can feel this force against your hand as you are decreasing the volume. You're basically making the insides of the balloon smaller, right, when you press on it. So what we say in terms of science is that the volume of the balloon, right, is inversely proportional to the pressure. That is, the higher the pressure, right, the smaller the volume of the balloon. Now we're going to introduce another concept with the balloon, and that's temperature. Inside of this container, I have some liquefied nitrogen, and the reason I have this here, nitrogen is normally a gas at room temperature. It's about 80% of the air that we breathe. But the reason I have it here is that it's very, very cold. Now we're going to get a chance to think like a scientist again. The temperature is about minus 320 degrees Fahrenheit. I'm going to put this balloon in there so we can get some sort of relationship between the temperature and the volume of this balloon. So as we put the balloon in there, what we're going to observe is the temperature, the volume of the balloon gets smaller. When I take it out, the volume of the balloon, as it warms up, it's going to get bigger, right? Now, from a law standpoint, this is what's called the ideal gas law, right? It's the pressure and the volume are inversely related, but the volume is directly related to the temperature. And this little experiment proves that. But then when we get into a theory, perhaps we want to know, well, why does it actually do that? And we talked a little bit about this last time. It's because we believe that molecules are tiny little moving marbles, and they're banging around in there, and they're trying to get out. And this theory is what's known as kinetic molecular theory, kinetic meaning moving, and molecular meaning molecules. These moving molecules start to slow down when you cool them down, so they're not hitting the sides of the balloon as hard anymore, and the balloon collapses. But as they warm up and get back to room temperature, then they start to hit the sides of the balloon harder, and the balloon expands. So we've taken these experiments that we saw and had a law that allows us to predict the relationship of volume and temperature and volume and pressure, and we can translate that into a theory using the kinetic molecular theory. Mathematical models are very effective in chemistry and physics and engineering to predict things with a high degree of accuracy, such as where planets are going to be at any particular time, or how to design a bridge, and so forth. As we'll talk about next time, however, quantum mechanics or quantum theory is a very complicated mathematical model that allows us to predict the structure of atoms and molecules very, very well, right? The big math and religion question, however, is who or what is the originator of all these physical and mathematical laws? And in Feynman's quote that we gave earlier, he hints that this is actually God. Mathematics spells out God's rationality for the universe, and I think that's the important thing to leave you with respect to mathematics here, is that rationality of our universe and using mathematics to explain it is, to me, very convincing evidence of the hand of God. And using mathematics to explain something is a little bit different than what we're going to get into next, which is evolution and creation. Just a couple of terms to familiarize yourselves with. Darwinism claims that all living creatures are modified descendants of a common ancestor that lived a long time ago. Although that's not exactly what Darwin claimed in his book On the Origin of Species, and we'll get to that a little bit later. Neo-Darwinism, which is a little bit more modern, claims that these modifications are the result of natural selection being acted on random genetic mutations. So Darwinism and the term evolution, they really mean the same thing. In evolution, we have two types of evolution. We talk about microevolution. This refers to small-scale changes within a species over a relatively short amount of time. For example, in breeding animals or bacteria's resistance to antibiotics over a short amount of time, those are all what we consider to be microevolution. Whereas macroevolution refers to evolutionary changes over long periods of time with new species emerging. And this is the type of thing that you would see in the fossil record. Atheist and evolutionary biologist Jerry Coyne believes eventually that science will explain everything in the universe. He also says that Charles Darwin's book On the Origin of Species, and this was written in the later 1800s, Coyne says that this is the greatest scripture killer ever penned. Having read the book again recently, I find nothing in the book that really sends that signal. Well, from the On the Origin of Species by Charles Darwin, and I'm quoting on this, and this is Darwin writing, I see no good reasons why the views given in this volume should shock the religious feelings of anyone. It is satisfactory as showing how transient such impressions are to remember that the greatest discovery ever made by man, namely the law of attraction of gravity, was also attacked by Leibniz, who was a famous mathematician in the 1600s, as subversive of natural and inferentially of revealed religion. A celebrated author and divine has written to me that he has gradually learned to see that it is just as noble a concept of the deity to believe that he created a few original forms of life capable of self-development into other needful forms as it is to believe that he required a fresh act of creation to supply the voids caused by the action of his laws. It is Darwin's proposed analogy, which follows, that is often used by atheist scientists to get God out of the picture. A few pages later from the quote that I just gave you, Darwin states, an analogy would lead me one step further, namely, to the belief that all animals and plants are descended from some one prototype. But analogy may be a deceitful guide, he says. Nevertheless, all living things have much in common in their chemical composition, their cellular structure, their laws of growth, and their liability to injurious influences. In other words, Darwin never said that all life had one common ancestor or prototype, nor did Darwin even oppose a theory for the origin of life, nor does Darwin ever attack religion. It's often been said that Darwin's theory of evolution gave atheists a reason not to believe in God. Right? Atheist Jerry Coyne's basic premise is this: if you can't prove the existence of something scientifically, such as God, it can't be real. But John Polkinghorne points out that theology bases its post mortem hope on reality inaccessible to scientific investigation, the faithfulness of a living God. I think what's absence from atheist arguments against the existence of God is really any knowledge of the reality of the good news of Jesus Christ. For me, the bottom line on evolution is I don't think that accepting evolution conflicts with I believe in God the Father Almighty, creator of heaven and earth. However, I do have a hard time believing that all life has a common ancestor because I see no definite scientific proof for that to me. One alternative theory to evolution is the concept of intelligent design, which has really come about in the last 20 years or so. Intelligent design proposes that an intelligence created and microengineered life forms, and that intelligence is God. Michael Behe, who is a biochemist, he's a leading proponent of intelligent design. His basic premise is this: the complexity and origin of life, even at the cellular level, can't really be explained by evolution. An intelligent source such as God must have been involved, and that life was purposely designed. Right? Behe tries to put the complexity of life into perspective. When we talk about mathematical models, for example, laws of motion, predicting planets, and so forth, those types of theories are relatively easy. You've got a very small number of variables to deal with, right? Whereas in the study of evolution, it has what he refers to as structure of essential complexity. Basically, evolutionary biology has to take into account geological concerns, meteorological ones, and particularly things that occur at the molecular and atomic level. These processes at the time of Darwin were not understood at all. Again, they didn't really even know atoms and molecules existed at the time. But at the best, Behe says that modern evolutionary biology can tell us what happened, but the sticking point, as it was for Darwin, is not so much what happened, but how it actually happened, what caused the events to unfold the way they did, right? The bottom line on intelligent design, it says that the biochemical complexity of living organisms is simply too great to have happened on a random basis, and God must have been involved with this, right? We'll have much more to say on the atomic and molecular level of things on the next lesson. I hope you'll join me for that.